We're all getting pretty used to leaning on AI assistants for, well, almost everything. But what if I told you that their judgment, the very core of their usefulness, can be hacked? Today, we're diving into the hidden biases that can make even the most advanced AI completely vulnerable to manipulation.
Really think about it for a second. Would you let an AI choose the single best resume for a super important job? Or decide on the most critical piece of software for your entire company? These are huge, high-stakes decisions, and we are increasingly handing them right over to an AI. And look, this goes way beyond just asking an AI for a list of suggestions. We're talking about a whole new paradigm that researchers call LLM as a recommender. In this setup, the AI agent doesn't just suggest, it decides. It sifts through hundreds, maybe thousands of options, and picks the one single best choice, all by itself, with no human checking its work. On the surface, the process seems pretty straightforward, right? You give it a goal, say, find the best resume. The AI scans a huge pile of them, and then it hands you what it thinks is the one single optimal choice. This is already happening in recruiting, e-commerce, even in academic research. But here's the million-dollar question researchers wanted to answer. How reliable is that final recommendation? Really? So how in the world do you test an AI for biases it might not even know it has? You can't just ask it because its own incredible intelligence can actually cover up its flaws. No, you have to be clever. You have to design the perfect trap.
And here's the key insight. You can't expose an AI's bias by giving it an easy choice. If you ask it to choose between, say, a Nobel Prize-winning paper and some random blog post, of course it's going to pick the right one every time. Its reasoning is just too powerful, and any hidden bias stays, well, hidden.
And this right here, this visual, it gets to the absolute heart of the experiment. An AI will always pass an easy test. The real test, the moment of truth, is when you make the choice much, much harder. You pit the best option against something that's only slightly weaker. It's in that gray area, that moment of difficulty, that an AI's hidden biases can suddenly grab the steering wheel. So, to create these tricky scenarios, the researchers developed this brilliant technique they call the calibrated quality margin. And this is the secret sauce for setting that perfect trap. It's all about precisely engineering a tiny quality gap, so there's still a right answer, but the choice is just hard enough to tempt the AI into making a mistake if it gets nudged by a bias. And to actually put this into practice, they built this whole sophisticated pipeline. First, they grab real-world data and clean it up. Then they figure out what makes something good by extracting key attributes. Next, they build those difficult pairs with that precisely calibrated quality gap. And then comes the final genius step. They sneak a subtle manipulative bias into the slightly weaker option, just to see if the AI will take the bait. All right, so what were these subtle tricks? What kind of bait did they actually put in the trap to fool these incredibly advanced AI models? Well, they pulled out a whole toolbox of cognitive biases, many of them borrowed straight from what we know about human psychology. Some were simple, like just putting the bad option first to see if position matters. But others were much more devious and tailored to the specific scenario. For instance, when testing an AI on hiring, they might take a weaker resume and just slip in a fake endorsement like this one. This is designed to trigger what's called authority bias, making the AI give way too much weight to an opinion from someone who sounds important. Or for something like an academic paper, they could try a different trick. They'd take a good, but not the best, paper and add a fake popularity metric. This taps into our all-too-human bandwagon bias, that feeling that if a lot of people like something, it must be good. Or, and this is kind of wild, they could be way more direct. In some tests, they literally hid a system command inside the text of the weaker option just to see if the AI would blindly follow instructions, even if they made zero sense. That's a test for instruction bias. Okay, so the trap is set. The bait is out there. How did some of the biggest names in the game, models like OpenAI's GPT-4o and Google's Gemini 3 Pro, actually do when they were put to the test? Well, the results are pretty jaw-dropping. In the job recruitment test, Google's Gemini 3 Pro was a solid 83.5% accurate when there was no bias involved. But the moment that fake recommended by the CEO line was added to a weaker resume, its accuracy absolutely plummeted to just 41.5%. Just let that sink in. That is a 42% drop in performance. The AI consistently picked the worst candidate, all because of one single, completely fake endorsement. That little trick was enough to make it ignore its own analysis of skills and experience.
And it wasn't a fluke. The same exact thing happened when it was reviewing academic papers. The model started out with an amazing 95% accuracy. But when a weaker paper was stamped with a fake but prestigious name like Google DeepMind or MIT, the AI was completely swayed.
Accuracy dropped by 38%. Think about what that means. The AI was consistently fooled by the shiny allure of a famous name, totally ignoring the actual quality of the research right in front of it. It chose prestige over substance.
And it's not just about authority figures. What about online shopping? What happens if you add a tag like bestseller or sold 50K plus units to a slightly worse product? You probably guessed it.
Yup, accuracy took a nosedive of nearly 25%. It turns out even the smartest AI is a total sucker for marketing hype. It falls for the exact same social proof tricks that get us humans to click buy now.
So, okay, clearly this is a massive vulnerability. These AIs that we're starting to trust can be tricked, and pretty easily too. So the really important question is, can we fix this?
The researchers tried two main strategies. The first is basically like giving the AI a little pep talk in its instructions, warning it to resist social influence and verify authority claims. The second method is way more intense. It's called supervised fine-tuning, which is like sending the AI to boot camp. You retrain it on thousands of these tricky examples until it learns to ignore the bait and focus only on the facts.
And both of these methods actually worked to some extent. But here's the catch, and it is a really big one. The exact same techniques you can use to train an AI to be more fair and objective can be used by someone else to do the complete opposite. A bad actor could use fine-tuning to secretly and deliberately train an AI to be dangerously biased.
And that leaves us with the really critical and, frankly, unsettling question for the future of AI safety. As we build these incredibly powerful decision makers and weave them into the fabric of our lives, how do we build the safeguards to make sure we can actually truly trust their judgment?